My name is Terry Van Bell, and it's my distinct pleasure to introduce Mohammed Ben-Demi and Darren McIntyre from Maple. I worked at Maple back in the mid-90s, and I always thought it was a great product. And you know, since I've been here at Google, every once in a while I come across projects and I think, oh yeah, Maple would be really nice for that. It would be great for that. So I was very pleased that they could show up. I just wanted to mention that this talk is going to be going to Google Videos, so please keep any confidential information out of the Q&A questions until maybe later on if you want to ask it in person or something. All right. Thanks.
Thank you, Terry, and thank you for coming again. Again, my name is Darren McIntyre. I'm the Vice President of Sales and Business Development at Maplesoft. It is not my job today to bore you with a number of PowerPoint presentations. This is a tech talk, so we're going to get Mohammed up here and talking very shortly. Wanted to ask a quick question, just a poll of the group who's familiar with Maple today, just by a show of hands. For video, that was about 25%. Is anyone familiar with the MATLAB suite of products? That would be MATLAB, Simulink, Simscape. By show of hands, that was more like 90%. Our company is a mathematics software company. We feel that anywhere mathematics is done, anywhere computation is done, we feel that our product has applicability. We play nice with other pieces of technology, that being MATLAB as well as Simulink, and Mohammed will go into some additional detail for you in a minute. So just a quick couple slides from me, mission statement here. We feel we're the leading provider of trusted high-performance software tools for engineering, science. We got our roots based in education, but branching out into the commercial market space. What we're trying to do is building a very high-end computational tool that has the world's easiest to use interface, a very simplistic, easy to use interface. And you'll see that in Mohammed's demonstration in just a few minutes. So one more slide from me. Started as a research project here at University of Waterloo back in the late 80s, so we've been in business some 20 years. Approximately 2 years ago, we introduced that new way to access that very powerful mathematics-based engine. And that is inherent inside of Maple 10, which we released a couple years ago, and Maple 11 that we released back in March of this year. We have about 150 employees, half in R&D, so we're very technology-based, and we do have very strong ties back to the academic space. I'd like to introduce Mohammed at this point in time. That was my last slide. I just wanted to briefly introduce the company in the background, and now we'll launch right into a demonstration of Maple itself.
Okay, thank you, Darren. Okay, just before I start my presentation, I would like to thank Terry, and also I would like to thank Google for the opportunity for us to come here and do this tech talk, so I can go back home and say I've been to Google. Maple is a tool that will allow you to do mathematical modeling and simulation. And it can go beyond that. So what I'll do, I'll just do a quick demonstration of Maple as a mathematical tool, and then we'll go into some other add-ons. So what we have here is a worksheet where you can seamlessly mix your mathematics with your. You can seamlessly mix math with text, with images, with graphics, and so on. So what I'll do, I'm just going to type here an expression. So we say x squared plus sine of x divided by x, and then plus, let's say 11 divided by 3. Maple 11 has a 2D equation editor that will allow you to type in your equations as equations using real mathematicians, unlike other tools where you have to code your equations or have them hidden in cells. The Maple document, or the Maple document interface, was meant to make the usability more of an easy thing to do when using the software. So what we have is a context-sensitive menu that will allow you to right-click on any mathematical expression, and then Maple will give you a list of commands that you can apply to that expression. So here we can see that we have like differentiate, evaluate, factor, integrate, and so on. So if I just pick let's say, optimize, and I want to minimize the expression. So we click on the minimize, and then Maple will minimize the expression. It'll give me the results there. I can also right-click on this, and we can do number formatting. So we can display our results in scientific notation, engineering notation. We can also specify the number of decimal places, and then we click apply, and then Maple will apply the formatting there. In some cases, a lot of people, they include equations in their documents, and when they go back to the document, they don't know where the equations are coming from. So what we've done, we can make annotations. So we can select the expression here, and then if we get to the formats, and then we say annotate selection. So I can say, okay, this is a reference, and it's coming from a book called Math and Modeling, and then page 1, 2, 3, for instance. So now when I hover over my expression there, I can see the little reference that tells me where that equation is coming from. Entering mathematical symbols is very easy. We have a number of palettes that give you access to over 1,000 different mathematical symbols. So this is the favorite palette, and we also have the expression palette there. And you can see we have integrals, derivatives, summations, basic functions like the sines, the cosines. So if you need to do an integration, we click on the integral symbol there, and then we can say, okay, we go from x0 to x1, and then we want to integrate the expression x squared and times the natural log of x plus 1 with respect to x. And if I press enter, so Maple will do the integration, and it gives me the results, as you can see there. We can also use, let's say, summation there. We do sigma going from k going from 1 to, let's say, n, and then we want to sum up all the k squared, and then we press enter, and then Maple will give me the result. Again, applying the context-sensitive menu, I can right-click on the expression there, and let's say I want to factorize. Click on factor, and then Maple will factorize the expression for me. Working with matrices, we also have a matrix palette there that will allow us to create different types of matrices. So if I click there, we can specify the number of rows and number of columns. So if I just type M1 here, and then we're going to create, let's say, a 3x3 matrix for simplicity. And we click on Insert Matrix. Here you can see that we have different types of matrices that we can create. We can create random matrices, identity. We can also specify the shape of the matrix, and also the data type. So in this case, I just want to enter an empty matrix, so I can start typing random values here. So that's my matrix there. Now, if I right-click on the matrix, now you will see that now I have things like solvers and forms. I can do LU decompositions. I can do queries on the dimensions, the rank. I can also do like the inverse, the determinant of the matrix, and then Maple will give me that. I can also use, so if I do M2, and M2 is the inverse, so I just do M1 to the -1 and press enter, and the Maple will give me the inverse of the matrix. I can also multiply the two matrices, and this will give me the identity matrix. The other thing that we could do, you can work with numbers, but you can also work with symbols. So if I do, let's say, A, B, and then C, if I press enter, now if I press enter, we have a matrix that depends, or the inverse matrix depends on the parameters A, B, C. And if I do simplify here, to tell Maple to simplify the products of M1 times M2, press enter, and now we have also the identity matrix when we multiply the two. Working with the large matrices, I'm going to create a very large matrix. It's going to be a 1,000 by 1,000 matrix, which is a very large. And I'm going to choose random matrix. I don't want to fill out a 1,000 by 1,000 matrix, and the data type is float. If I press insert here, oops. So that's my matrix there. Now, I'm going to compute the inverse of large M. So I'm just going to do large M to the -1. So this is a very large matrix. How long do you think it'll take to compute the inverse of the matrix? It's a 1,000,000 element matrix, and any idea? Yes. Anyone want to guess? 5 hours? 5 seconds? Okay, I'm going to press enter right now. So it'll take about a second or two to compute the inverse of a very large matrix. Now to view the elements, all I have to do is just double click, and then we can see the entries there, or the elements, and you can see it's 1,000 by 1,000. We can also view the image there, and that will give me an idea about the structure of the matrix, and you can see it's a very dense matrix. A quick test is to multiply the two matrices, and this should give me the identity matrix. Again, multiplying two very large matrices. There it is. If I double click now, again, we should have the identity matrix. And you can see that we have 1, 0, 0, 0, 0, 1. And I can view that by using the image, and we see that we have a diagonal matrix, which is exactly what we expect. The other thing that I'm going to demonstrate here is using Maple to solve differential equations. Maple does solve differential equations symbolically as well as numerically. It can also solve differential algebraic equations. This is one of the strong features in Maple. So what I'm going to do here, I'm going to define ODE1, and I'm going to use a numeric example first and then a symbolic one. So we're going to enter the ODE. Again, entering differential equations in Maple is very simple. We use the prime notation, which is like x double prime means the second derivative with respect to time, and then plus x of t squared plus 1, and then times x prime of t, and then plus x of t, and this is equals to 0. So this is okay. This is a second order nonlinear differential equation. If I right click, what we have here is, you can see now in the context sensitive menu, we have solve differential equation and solve differential equation interactively. I'm going to choose the interactive one, and that will give me this assistant that will allow me to solve this differential equation again without having to use any commands. I mean, so far, I have not used a single command. It's all using the context sensitive menu or using the shortcut keys. Here, I can add initial conditions or boundary value conditions. So we say at time t equals 0, x is 3. And then x prime at time t equals 0 is going to be 0. And then we say add. And then we say done. So these are the two initial conditions that we need to solve this ODE. Now if I go solve numerically, here on the left-hand side you see the different solvers. And Maple will always pick up the appropriate solver depending on what type of differential equation we're trying to solve. I have to provide the value for time. So if I say at time t equals 5 and I click solve, Maple will give me x and x prime at time t equals 5. I can also create a plot, and then the plot will plot the solution of that differential equation, which I can then return to my worksheet. I can also return the numeric procedure that generates the solution, or I can return the Maple commands that will generate the solution as well. If I click quit, now we have the solution there. So the next thing I want to show is importing data into Maple. So if I use the tools, assistants, we have a lot of assistants, again, that will allow you to do things without having to know anything about the commands or the syntax. So we have a curve fitting, we have data analysis, import data. So this is the one I'm going to use here. So you can see the file formats. We can import Excel files, MATLAB files, audio files, image files, and so on. I'm going to select Excel. And I'm going to look for an Excel file in my Maple folder. Next. And then we say done. So this will import the data. So we have 25,000 pairs of points. Again, the context-sensitive menu will allow me to visualize this. Again, just by right-clicking on the data there. And then we go plots, and then we have the plot builder. And again, the plot builder is an assistant that would allow me to create different types of plots. And then we say plot. So Maple will plot the data. So that's the data there. If I want to manipulate the data or change things in the data, again, using the context-sensitive menu, right-click, and then we can go symbols, and then we choose points. Right-click, we can choose to change the color, say red, for instance. We can also use the drawing tools here, so we can add text for annotation purposes. So we can annotate the plot. So we say 2D point plot example. We can also add tag. Instead of math, we can also use mathematics for annotation purposes. So if we want to add, let's say, pi there, k, going from 1 to n, and then we have, let's say, 1 plus k squared. We can also can highlight areas in the plot. So this was a demonstration of importing data and visualizing data, again, without having to use a single command. It's all done using the assistant and the context-sensitive menu. The next example I'm going to show you is a 3D animation. So we're going to define an expression here. So x plus r times y multiplied by the exponential of minus x squared plus y squared. Now again, if I right-click on this, again we have the context-sensitive menu, and then we have the plots, and we go to the plot builder. And here I'm going to select animation. So it's a 3D plot. Here the x and the y are the x-axis and the y-axis. We can set the ranges. We go from minus 1.5 to 1.5, and then the same thing with y. And r will make it go from 1 to 10. If I click on plot, Maple will generate the animation. Again, we can right-click there. We can make changes, style, surface without the wireframe. We can add a lighting scheme. And we can play the animation here, so you can see the animation. We can also rotate this in real time, just using the mouse. And you can also export this in different formats, bitmap, GIF, JPEG, and so on. I said I was going to do a symbolic differential equation, which I didn't. I'll do that right now. So we're going to define a differential equation, say m times y double prime of t plus b times y prime of t, and then plus k times y of t. And this is equals to, let's say, alpha times cosine of omega times t, and then plus, let's say, beta. So this is a differential equation. The initial conditions, we just do y of 0 is 0, and y prime of 0 is also, let me make this 3. So these are my initial conditions. Now to solve this differential equation, all I have to do, even if you have to use the command, it's very simple. We just do desolve, and we solve in the ODE2 with the given conditions, and we're solving for y of t. And this will give me the solution in terms of all the parameters of my system. So you've got the A, B, the alpha, beta, and omega, m, and so on. So we have the solution there. And now what we could do, let me show you something cool here. I'm going to assign that solution. Now I could, if I type y of t here, if I right-click on it, again, using the context-sensitive menu, we can convert this into any of the languages that we have there. C, Java, Fortran, Visual Basic, and MATLAB. If I do C, we convert that into a C code that we can then use in some other applications. Maple does have a number of packages, and these packages are libraries for doing things like, if you're doing statistics or linear algebra. If I just do with statistics, this will load the statistics package, which means it loads the functions in that package. And there are a large number of functions that we have in the statistics package, as you can see there. There are about 35 different distributions. There are a number of statistics plots. Can generate random numbers. We can do all kinds of things. So let me just do a quick example here. If I define x as a random variable, we use a normal distribution here. Then we take 1 and 0.5. Now I'm going to create a sample of that. So if I do sample x, and let's say we take 100,000 samples, press enter, that's my data there. Again, if I right-click here, now we have statistics in the context-sensitive menu, and then we can do all kinds of visualization. We can create bar charts and histograms and the summary. We have quantities like geometric mean, standard deviation, the mean, and so on. So let's do a histogram. And that's the histogram there which we can edit. I can change the color. I can change the bin width there. I click update. When I click on quit, then Maple will return the histogram for me there. So there are a lot of functionality in the statistics package. We have a number of add-on tools. There is Darren mentioned how many people use ask how many people use MATLAB and Simulink, and there are quite large number of hands. We do have tools that will allow you to do your mathematical modeling in Maple, and then you can convert all that stuff into a nest function or a Simulink block that you can simulate in a Simulink environment. We also have block importer that will allow you to bring in Simulink models and then convert them into mathematics. And you can simplify the model, and then you can send it back as a Simulink block for better performance. So what I'll do, but before that, any questions so far? Yes? Okay, we get that question. Do you want to? Okay. The question is, how do we differ from Mathematica? Is that?
Mathematica has historically been our #1 competitor, specifically in the academic space. We feel that the work that we've put into the interface of Maple to make it extremely easy to use, the 2D editor that Mohammed showed, the assistants, the tutors built into the software tool make it immensely easier to use than that of Mathematica. We feel that the power between the two systems is somewhat comparable, but we feel that for engineers and scientists, we do reach out to other software tools like that of MATLAB, Simulink, for connectivity. In an engineer's tool chain. So we feel that from a connectivity standpoint, we feel that Maple is a much better tool than that of Mathematica, and as well from an ease of use standpoint, we also feel that Maple is superior. In the past as well, Mathematica is not a very open system to allow access to view the code inside of Mathematica. 95% of Maple has always been open and still is. So if you wanted to see the coding that goes into the 4,000 functions that are physically a part of the math libraries, you can go in and actually view the actual code itself. Any other questions before we continue? Yes?
So if the code's viewable, then what about like intellectual property?
The question was, what about intellectual property if the code is open? There is a subset of Maple that is protected that we do not allow access to readily to users. We feel that it is important to open up the math libraries to allow people to verify their results, and that's really why it's there. Maple does own the IP to the system, and we don't feel that there are any holes there that are opening us up in any insufficient way. Anything else? Okay, we'll continue.
Okay, thank you. Okay, since there was a question about the Maple open environment, let me just show you a simple example how you can view the code of some of the functions. So if I there are a number of functions in Maple, obviously. So there is one, it's called isPrime, which checks whether a number is prime or not. So if I do isPrime 17, so it's true. So if I want to view the code of the isPrime function, what I'll do here is print isPrime. And actually, the code is written in the Maple language. So Maple does have a programming language that we can use to write code. So this is the code that we use for the isPrime function. So there are a number of functions that you can view. About 90% of the Maple commands are written in the Maple language, and they can be viewed. You can also modify them. You can make changes, and then you can save them. You can also create your own libraries based on what we have in Maple. Now, using Maple programming language, again, is very easy. I'll just do a simple example here. Just for, if I do, the name of the program is going to be prog, and then we say proc is a keyword that starts a procedure in Maple. And then we say n1. N1 is going to be an integer. We don't have to specify what data type is, but sometimes we can do that. Yes. Thank you. So I was going to do the same thing here, integer. And then I'm going to define some local variables. So we define, say, m, I, j as local variables. And then we're going to use the for loop. So we say for I from 1 to n1 do. And then for j from 1 to n2 do. So what we're going to do is create a matrix. So mi, we just put it's I plus j. And then what we do is AND. We need to AND the first do. And then AND the second, and in the second loop. And then we AND the procedure. So this is a Maple program. We're using 2 for loops. We could also use like if statements and all kinds of. And then here we can run the program by, so prog, if we do 3, 4, oh, I forgot something here. What we want to return is the matrix M. So the matrix, so N1, N2, and then M. Oops, I forgot to close this. And then we have our matrix there. If we choose something bigger, we have a 30 by 40 matrix. If I double click, I can see all the entries of my matrix. Okay, the next thing I'm going to do here is to show you BlockBuilder and block imports. As I mentioned, the BlockBuilder is a tool that will allow you to convert mathematical models into Simulink. So if I do with BlockBuilder, this will Oops. Okay, that's my BlockBuilder, and these are the commands in the package. And if I do question mark BlockBuilder, this will open up the help page. And these are the commands that are built in the package. So BlockBuilder, I mean, as it says there, exports a dynamic system to Simulink. So first we have to create what we call a system object, and a system object could be a system of differential equations, it could be transfer functions, it could be state space matrices. And then we can generate the code, which is an S function that could be a C code or MATLAB code. And then we can do manipulations like, the characteristic polynomial, gain margins, Gramians, and so on. Now if I go to an example, so here we have a number of examples there. So I'll just go to the mobile robot there. So this is a system that was modeled in Maple, and after it was modeled in Maple and tested and it was working fine, then we wanted to convert that into a Simulink block. So initialization here just means that you load all the libraries. System definition. So we have the parameters and we have all the variables in table form. So here we have the robot chassis radius and the moment of inertia, the mass, the wheels, the moment of inertia, the DC motor, resistance and inductance. And then we have the variable definitions, what each variable means. So x, t, y, t means the robot positions, the x and y coordinates. And then here we have the model. And the model is just a system of differential equations that we need to solve. So these are defining the system. What we have to do is assign, give the initial conditions, and also the number of parameters there that we have to give them values, and then we do the simulation. So with the input is given by this piecewise function here, and then we're going to view the output by solving the system of ODEs. So this is the robot head, and this is the XY positions of the robot. So this is the simulation here. What we do is run this animation here that will show how the robot moves along the trajectory that we have there. And then we do the export to Simulink, and this is the last piece, which will convert all that into a Simulink diagram. Here we have the 2 inputs and we have 5 outputs, and we have the different states. We can also view the parameters, the resistor, the mass, the moment of inertia, and so on. These are the values. We can also change these mask labels if we want to. And now if I go generate, this will generate the code. I can preview the code. So this is a code that's generated automatically. And now we're going to build the block. This will open up MATLAB and Simulink. Okay, that's MATLAB. Yes, sure. Okay. Yeah. Okay, try hard. It tries harder than optimize. To be honest, we have 3 options. There is the what we use in here behind the scenes is the code generation of Maple, and it has the option to add the optimization, so you get an optimized code. The difference between optimize and or try hard, I mean, I'm not entirely sure, but it's it does. I think it gives you a better code, I think, but I'm not entirely sure what try hard means. We had that question this morning. I wasn't expecting it, to be honest. So this is the robot, or the block that we just created using BlockBuilder. If we double click here, again we have all the parameters there. Now if I apply an input, so we just take we could take a sine wave or a step. Just take a step here. Okay, we'll apply the first input. I'm going to use a second step input. And we're going to use a scope. So I'm just going to use two scopes just for X and Y. Now if I run the simulation, it's done. So this is my X position there, and this will be the Y position. So this is, uncontrolled output. Then we could apply a PID controller so we can control the output, so we can get the output that we want. So this is a BlockBuilder. As I said, Block Importer does the inverse, so it gives you like a Simulink model, and it converts it into equations that we can simplify and reduce the number of equations, a lot of redundant equations, and then give you a better code for that. One last thing that I'm going to demonstrate here is optimization. Maple does have optimization functions. We have the optimization, which is a built-in optimizer, and this is basically, it does local optimization. It does LP solve, there is the least square solve, there is the maximize, minimize, nonlinear programming solve, and the quadratic programming solve. We also have a global optimization toolbox. That's an add-on that would allow you to do global optimizations. So let's say you have an objective function, and you have a number of constraints, and you have bounds, and you want to find the optimal solution. Then Maple will allow you definitely to do that. In some cases, you have test data, you have input, output, and then you have a model that you want, sometimes called parameter identification. So based on the test data, you want to find the values of the different parameters that will give you the best or will fit that data. I think I have an example here. Instead of me creating one from scratch, I'll show you one. So we have global optimization, and this actually was done by a company. So what we have here, so this is the test data. So we read the data and then we plot it, and that's what we have there. And then the model function is given by this expression here. As you can see, it's nonlinear, where what we need to find is the A, B, C, D, and the K. And those have some real significance. This is actually a spherical lens. So here we substituted R by this value. So this is the model function that we have. We have the intervals for the different value, for the different parameters. We have A between minus 0.001 and 0.001. Same thing with B, C, D, and K is between minus 1 and 1. So the objective function will be the sum of the least squares between the actual value and the calculated value. And then we'll run the global solve command, and this will find the values for A, B, C, and D, and K. And what we do is plug them in the solution, in the equation that we started with, and then we create the plot. So this is what we have here. And if we plot the two together, you see that we have two curves, one on top of the other. And then we verify the results here. So the regression coefficients, we have A, B, C, and D. And then we'll look at the error. So it's in the region of 10 to the minus 6. So the results are very, very good. So this was the global optimization. You can also use the optimization assistant. So if we go optimization, this will allow me to define an objective function by clicking on the edit button there. So I can type in an expression there. You could have as many variables as you want. We can add the constraints. So we can add constraints. You could have as many as you want again. And we can add all the bounds, so the intervals of those parameters. And then here we have, you can see these are the local solvers, or the local optimizers. And this is the global one. And the global one does have different options. There is branch and bound, there is multi-start, single start. And we can choose whether to minimize or maximize. And once you enter all that information, you just click on solve, and then Maple will solve. And it'll give you the optimum value as well as the values for the different parameters that you need. How are we doing for time? Are we? So we have about 10 minutes. Any questions? Okay.
I have 2 questions.
Yes, sure.
The first one is, I used an earlier version of Maple.
Okay.
It's very good.
Okay.
I had a lot of trouble trying to find out if the function that I was looking for is somewhere in these packages. So I was looking for something
Okay.
like, how do I find stuff?
Okay, good. The question is how to find built-in functions in Maple. Yeah, that's very easy. What you do is, remember I did the question mark for help. So if you do question mark, you're looking for functions, type functions. You want an index, comma, index, and then press enter, and the Maple will open the help page and all the functions that are built on the software with a hyperlink, so you can click on the function name, and then Maple will give it a help page on the function. So add, if I click there, I'll have the help page on the add and how it works with all the options. And usually at the end of the help page, there is a number of examples that you can copy and paste. It shows you how to use the add function.
So you have to know what the function is called.
Well, in here, I just did function index, and it gave me a list of all the built-in functions. So, okay. What's the second question?
The second question is about factorize.
Okay.
I want to be able to factorize to minimize the number of operations between the arguments that I have. So I want to be able to take an expression and produce the minimum number of operations for my computer to do. And factorize seems to do something that makes it look nice mathematically. It doesn't necessarily do the minimum number of operations.
Okay.
Doing that.
Okay, so the question is how to, is there a built-in functionality that will minimize the number of operations? So when you, for instance, simplify or factorize whatever, you just want to reduce the amount of computations that will, that's a good question. I don't know the answer to that, but it's something that we can definitely get back to you on. And I'm not entirely sure if there is a built-in function that you can say, okay, go and minimize the number of operations. I've seen something that's probably when the optimization comes in, but that's definitely with code generation. So if you, but I mean, I'm not going to go into details. I don't know the exact answer to that, and we can definitely get back to you. What version of Maple are you using?
It was way back. It was version 10 or something.
Version 10 is recently, it's a recent release. It's just the previous release.
It'll be 6 now.
It'll be 6. Okay. Yeah, 6 is quite old. Yeah, I have seen an example where you get a summary of all the operations, you know, how many multiplications, how many additions, and so on. And there was something that reduces the number of operations, but I'm not entirely sure what it was. I think it's to do with the code generation and the optimizer that is built in Maple that does that. Okay? Any other questions? Yes?
What I've seen here so far is beautiful for mathematicians. Anybody who wants to really quickly put in functions and do all this kind of
sorry, could you repeat?
People who have to do math and are not very good at it.
Okay.
So you have people who are like ecologists who are very, very good at their particular branch of science,
Yep.
and then have to do a whole bunch of mathematics in order to prove their work.
Okay.
Do you have assistance or help or something in there for allowing them to know what to use to do the math they need to do to prove what they need to do?
Okay. The question is from the gentleman there is what he's seen so far is good for mathematicians, but it's not good for people who don't know math. Is there anything in the software that can help them?
Do you have a make it stupid website?
Okay. Okay. Well, using Maple is, as I said, it's widely used by engineers as well as mathematicians and scientists, and it does mathematics. But what you need to do is, for instance, you have I give examples of like differential equations. The mathematicians know how to solve these differential equations. People who are not mathematicians wouldn't know how to solve a differential equation. So what the Maple does, you give it the information, and it'll go and do the math for you. You don't have to do any mathematics when using Maple. Maple does all that. If you're looking for tools that will allow you to you want to create a system, use block diagrams and connect them and then get your equations, then Maple does have a number of options. There is a tool called Dynaflex Pro. So what you do, you don't have to do any mathematics. You start with a system, let's say you have a spring mass damper. So what you do using what we call model builder, so you have your ground and you have your spring damper, and then you have the mass. You just make the connection, bring block, which is the mass, and then the joint, which is the spring and the damping, and then Maple will translate all that into mathematics for you. And we've coming up with another tool called MapleSim. It's in development, and again, it's for engineers who don't need to worry about the mathematics. So they have a system, they can create it using components, like I bring a resistor, a capacitor, a spring, a damping coefficient, make the connections, and then run the simulation, and then get the results, and I don't have to worry about the math. Any other questions? Sorry? It does run on Linux, it does run on Unix, it does run on Macs, Windows. So it's a multi-platform, so you can run it on different platforms. It's not just Windows. Okay, so since we have a bit more time, so what I'm going to do here, just show you the another add-on, which is Block Importer. Is that okay? Or, sure. Okay, so what we'll do here, I might have this open. This is an F14 model, so I'm just going to run through it. So here we load the two libraries, the Block Importer and Block Builder. So what we do here is the import the F14 model. So what this will do, it'll let me just run this one more time. So we'll have Simulink with the F14 model, run the simulation here, and then we get our results. So what we've done here, this is the Simulink. So we import it into Maple using the import command, and then here we print a summary of the model. So we have 92 equations. So there's a lot of equations. We have 10 state variables. We have 2 inputs, 2 outputs, and 19 different parameters. So we use a simplify model, which is a command in Maple that simplifies the model. So we went from 92 equations to 12 equations. So we got rid of 80 equations. The parameters are the same, the inputs are the same, the outputs are the same. And then we do the simulation by solving the system of ODEs. And then we got the response. As you can see, if you look at that and you compare it to this one here, so you can see they are similar. So this is the result that we obtain in Maple, and this is the result in Simulink. Then we do the analysis here, so we can do the both plot. So we plot the phase and the gain. And we also plot the poles and the zeros and the step response when we apply an input to our system. And then here we have the gain margins. So again, once you simplify the model, then you can send it back to Simulink, and then you can run it in a Simulink environment. Okay, I'm going to stop here, and then we can use whatever time is left for any questions. Yeah, or if you need further information, we have an information pack here that you can take. It has all the information about Maple and all the add-ons that we talked about. Again, thank you very much. Thanks for the time and thanks for the opportunity.